Hello, my name is Atalar. I am a master's student in Bilkent University. I will present my project results about 64-bit digital correlator integrated circuit design. Let's begin. Correlators are widely used in telecommunication systems to detect the presence of a signal. In demodulators, correlators are used where received sequences compared with basis functions of the modulation scheme. Here we could see a 4QAM demodulator where phi1 and phi2 are basis functions of the modulation scheme. Requirements of the correlator module are the following. We have 5 input pins: clock, data input, program run, reset, and program input. Output pins are sync, sync number, and data polarity. Let's move on to logical behavior and architecture. I have stored the input data in a 64-bit shift register. Exclusive OR operation is used to compare the data and sync patterns. Sync signal is raised if data in the shift register matches with one of the patterns. I have selected an architecture which has less pipeline stages to reduce the sequencing overhead. Fully combinational logic is used in exclusive OR and error calculation stages. Comparison and selection operations are done in the second combinational logic state and output signals are assigned. This module has 65 clock cycles delay from the first input to the last output. I have used 0.35 micrometer AMS core library with worst case operating conditions at 2.2 volts. VHDL code is synthesized with Genus and post-synthesis simulation is done with Incisive for behavioral verification. Here at the top you can see the behavioral test bench simulation of the VHDL code. I have explicitly printed the error signals for visualization. At the bottom you can see the post-synthesis simulation of the netlist generated by Genus. Next, I have followed the Innovus design flow starting with floor planning, definition of I/O pins, followed by physical synthesis, placement and routing, finally clock tree synthesis. Post-route simulation is done for behavioral verification as well as TCF file generation for Voltus. For accurate power estimate and timing analysis, I have used Voltus and Tempus programs. Post-route results for correlator module is shown in the table. Here I have reported two designs. First one does not have a testing mechanism, while second one has chained scan flip-flops.